Think of a container with a mixture of gases. Dalton's law of partial pressures states that the total pressure is the sum of the individual pressures of each gas. P1, P2, P3, etc. represent the pressures of each gas in the mixture. These are called partial pressures. Recall that according to the ideal gas law, pressure is nRT over V. Notice that R is the ideal gas law constant, and since the gases are in the same container, their volumes and temperatures are the same. Thus, these terms can be factored out, and according to Dalton's law, the total pressure can also be written as the sum of the moles of gas times RT over V. Here's an example of using Dalton's law of partial pressures. 13.2 grams of carbon dioxide and 6.00 grams of helium are mixed in a 4.00 liter container at 300 Kelvin. Calculate the partial pressure of both gases and the total pressure. Because we have a mixture of gases, we'll use the ideal gas law to find the partial pressures for each gas. Then use Dalton's law of partial pressures to find the total pressure by simply summing the partial pressures. First, I'll convert the masses to moles using the molar mass for each gas. Next, I can use the ideal gas law to find the partial pressures. Note, the only term that's different is the moles of each gas. Now, I can sum the partial pressures to find the total pressure. The total pressure is 11.08 atmospheres. But note, the total pressure could also have been solved by summing the moles of the ideal gases. I could have used the total moles and reached the same total pressure to 3 significant figures. We can use mole fractions of gases in a mixture to keep track of the moles of each gas in that mixture. The mole fraction is denoted by the Greek letter chi. In this example, the mole fraction of gas 1 is the moles of gas 1 divided by the total moles in the mixture. And why would we need to know the mole fraction? The mole fraction can be used to find the partial pressure of a gas in a mixture. Here, the partial pressure of a gas is the mole fraction times the total pressure of the mixture. Here's an example of using mole fractions to find partial pressures. A mixture of gases contains ethene, nitrogen, and argon gases and exerts a total pressure of 2.65 atmospheres. The mixture contains 0.456 moles of ethene, 0.540 moles of nitrogen, and 0.730 moles of argon. What is the partial pressure of each gas? Notice that no volume or temperature conditions are given. The total pressure and the moles of each gas are given. We can find the mole fractions and multiply them by the total pressure to find the partial pressure of each gas. First, I find the mole fractions of each gas. I can do this by taking the moles of each gas and dividing by the total moles in the mixture. All the mole fractions should add up to equal 1. Then simply multiply the total pressure and each mole fraction to get the partial pressures of each gas.